And welcome to Chapter 4, Inter-VLAN routing. This one is pretty short compared to some of the others that we've had. They've got 38 slides in total. They're not all too bad. So we'll be having a look at the operations of Inter-VLAN routing, how it's configured, how we can use a router or a multi-layer switch to enable this to occur, and we'll do some basic troubleshooting of the configuration. So let's get stuck into the operation. So as hopefully you've remembered from the previous session, VLANs are generally operating at layer 2 of the OSI model, and we need to send traffic up to a layer 3 device for transfer between the virtual networks, just like if they were physical networks. So we call this inter-VLAN routing. So we forward traffic from one VLAN to another, and the options we can look at is the legacy. Now this doesn't scale very well. Basically we'll cover that in a second. Let's not get ahead of yourself, right? Alright, router on a stick is basically where we use a single router with a trunk, which is an acceptable solution. But for larger networks with a lot more traffic, we need to look at using multi-layer switches with switched virtual interfaces. This is very scalable and applies to large traffic networks. So the way we had to do it in the dim dark days, we had to have a physical connection for each VLAN. This is before trunking came about. So basically, to get from one virtual network to another, so for instance here in VLAN 10, all traffic destined for VLAN 20 would come up via a physical cable that is in a VLAN 10 port to one of the interfaces on a router. It would forward it out to the other network, which was for VLAN 20, and come back down to the same switch and be plugged into a port associated with VLAN 20 and be able to get to the destination. Now, as you can see there, we have a pretty big limitation on physical ports or interfaces on our router. Generally, routers are not high port devices, so this caused great limitations without spending a fortune in router equipment. So with the advent of trunking and the ability to use a single cable, router on a stick became the next option. So we basically have a Ethernet interface connected to the switch, and it's using the 802.1q trunk, and we have every virtual network running across the trunk. So each interface, that virtual interface on the router, corresponds to another network or VLAN, and we then send traffic that is destined between one VLAN and another up the trunk to the router, The router takes it off one virtual interface, puts it on another virtual interface, and sends it back. And we call, on the router, when we're using virtual interfaces, we call them sub-interfaces. And lastly, using a multi-layer switch, we basically set up the SVIs just like we would on a layer 2 switch. So we go to interface VLAN 10, give it an IP address, and do a no shutdown command. Do that for as many VLANs that we need, and then what we have to do is we've got to turn the IP routing function on in the multi-layer switch so that it operates at layer 3 and it can route traffic from one network to another. So why would we take the multi-layer switch option? Well, inter-VLAN routing at the switch level is much faster than router on a stick. We don't need external links to the routers for the routing function, and we can massage the process much easier, and it's going to be faster. Okay, we don't have all that travel time up to the router, the routing, and then coming back down. Morning, Brad. So on large campuses, we'll find that we have multi-layer switches that enable us to do that routing function. But disadvantage is large layer 3 switches are more expensive than layer 2 switching. So, but comparative to having multiple routers, will be a cheaper option. So how does this work? So in this example, we have VLAN 10 over on the left and VLAN 20 on the right, the multi-layer switch, and our virtual router. Okay, so within the multi-layer switch, we have a route processor, and it has internal switching with links up to the route engine and back down for each virtual network that it connects to. And each of them get assigned a interface with individual MAC addresses, just like if it was a router. When traffic comes in from VLAN 10, it's on the port and VLAN with the host MAC address as the source, and it's looking for that routing interface to pick it up and forward the traffic. So this, when it's sent up from the switch to the internal route processor, it's called a candidate. It then reallocates the destination MAC address and determines which port to forward it out of, and it changes the source MAC address to the VLAN 20 through the route engine, and that's now an enabled route and is forwarded on. Consequently, when a new frame arrives into the switch, it doesn't need to send it up to the route engine. It has a hashing algorithm that works on the switch ports and says, you're from host A going to host B. I recognize that. I'll just change the information and switch you forward, and that will be the solution from there on. So you can see here we have a much faster solution to having a router on a stick. It's an internal function, routing function in the switch with internal bus connections, so it's much faster than any cabling, external cabling we connect. And after that initial path determination, it does express forwarding down on the switch level, so it becomes much faster from the second frame onwards. So the scenario of router on a stick, we have router 1, so a single router connected to switch 1 with a trunk line, and switch 1 and switch 2 connected via a trunk as well. And we are running 3 distinct virtual networks. So we have 10, 20, and 99. Now, you'll notice here that our sub interface doesn't equal a VLAN ID, doesn't have to. It's just convention that we sort of name the sub interface the same as the VLAN number. That allows us to easily recognize the connected virtual network. So if we've only got basic configurations on those devices, router 1, switch 2, only switch 1 and switch 2 can ping each other, but for PC1 and PC2 they will be unreachable because they are on different networks. So the 2 switches are on 99, so they're directly connected, so they'll be able to talk to each other. VLAN 20 and VLAN 10 cannot connect to each other because they need to go through a router or a layer 3 device, and we haven't configured inter-VLAN routing at this stage. So we need to configure the VLANs, create the management interfaces, configure all of our ports, in other words, associate them with the appropriate VLANs that we're running with, and configure the trunk ports. So we basically have to do this on both switches. So just as a reminder, VLAN and then the number creates the VLAN ID. You then can optionally give it a name. So you do that for 10, 20, 99. You then go in and configure each of its SVIs that you need on that device. In this case, it's the management gateway. And you put the default gateway for that management network in, and you assign the ports that you need for the VLAN associations, and configure our trunk connection to the other switch. Now, up on the router, we have to do some little funky configurations. So we are required to do sub-interfaces. So this requires us to have an interface, the interface ID, followed by the sub-interface ID in the global config. Okay, so how is represented? Well, it's a dot. So after you have the physical interface ID, you put a dot, and that's followed by the sub-interface identifier. You then have to tell it what encapsulation to use. In this case, .1Q, which is representing 802.1Q to encapsulate the traffic. And you need to specify which VLAN is going to be native across the trunk. In other words, it will not receive tagging information. And then you've got to give each sub-interface an IP address. Rinse and repeat for all your sub-interfaces. You do not configure the physical interface. Okay. So down here, the physical interface, it has no encapsulation, no any configuration, no IP address. All what it is it's activated with no shutdown. So each of your sub-interfaces, do the usual description. You specify your encapsulation type, your IP address, rinse and repeat for all of your VLANs that you're using in the trunk. And then after that is configured, you have to have that trunk configured on switch 1 as well. And then you should be able to ping between the PCs. So some of the things you may want to check is show IP route to see that all the networks appear in the routing table. Show IP interface brief to show the summary of IP addresses have been configured correctly. Show interface will give you a full listing of all the interfaces, and show interfaces trunk will give you current status of the trunk interfaces. So with a multi-layer switch, we kind of don't need to do as much configuration on it. Okay, so we need to configure it pretty much the same as a normal switch, in that we give it the VLANs, the assignment of the ports that it needs. We create switch virtual interfaces. We may need to convert a physical port from a layer 2 switch port to a layer 3 interface. This allows us to connect that multi-layer switch via routing to a router. So we can share routing information and do everything that a normal router can do. Well, not everything. The basics of what a normal router can do on that multi-layer switch. And with the switched virtual interfaces configured for each of the VLANs that it needs to switch between, we can then route between the VLANs after we engage IP routing on the layer 3 switch. So basically with a layer 3 switch, we can just set them up and we basically will have inter-VLAN routing. So the steps are create the VLANs, just like we would do on a normal switch. Create all the switch virtual interfaces on the multi-layer switch, and then configure the access ports, assigning the appropriate VLAN numbers to the ports. And this is the crucial step here to enable our inter-VLAN routing, is we need to turn IP routing on. That's all what we need, IP routing in the global config, and that tells the switch to operate, to turn on that route processor and do routing functions. So from there, after that's done, you should be able to ping between your hosts through that switch. We only need to configure an interface as a layer 3 interface when we connect a interface to a router. It's not essential for inter-VLAN routing. But the commands you need to create that layer 3 interface is you go to the port with the interface command. And the command to change it to a layer 2 port to a layer 3 interface is no switch port. So that turns off layer 2 functionality and tells it to go to layer 3 functionality. You then configure that converted interface just like you would any other interface on a router. You give it an IP address and you connect it to the router, and you configure the routing protocol on that device so it can exchange its known routes with the router and vice versa, so it can forward traffic based on routing. So in the example here, we're using the routing protocol open shortest path first, OSPF, and the multi-layer switch will know 192.168.20 network, 192.168.10 network, and 10.10.10 network that connects to the router. So this is directly connected networks to here, and with OSPF it will forward these known networks up to router 1. So now router 1 knows these networks exist, and router 1 will exchange this network 10.10.20 with our multi-layer switch, so it knows the existence of the server network as well. So just to round off the configuration for the layer 3 switch, we use no switch port command to convert our interface. We turn on global IP routing. Make sure you've configured the interface with an IP address and subnet mask and no shutdown. Do your routing or static route, whatever we're using, and then verify routing and connectivity using the show IP route commands and the ping commands to confirm connectivity. Now, it's pretty straightforward. We've got some labs to do in this one, so this will all become clearer as you do the labs. So, possible problems with inter-VLAN routing. Missing VLANs. If you forget to create the VLANs on one of the switches, you won't be able to connect to the devices correctly. So make sure you've created the VLAN and make sure you've got host ports assigned to the correct VLANs. Otherwise, you won't be able to have connectivity to those devices. Trunk port issues. Each end of the trunk needs to be configured to communicate to each other. They need to use the same encapsulation types and they must be turned on. Switch port issues, again, most common one is not assigning the VLANs to the correct ports. Make sure your port is an access port, not a trunking port, and you've got a host connected to it. And make sure your host is configured for the correct IP address range for that VLAN. We haven't done a great deal of router configuration at this point, so ensure that your IP addresses are correct for each of your sub interfaces. Make sure they are assigned a correct VLAN ID for each of the sub interfaces, and make sure, it's not listed here, but make sure your physical port is activated. If you do not activate the physical port, all your sub interfaces will be down. Okay. So here we've basically got the same scenario that we talked about in the previous slide with the standard topology, and we have router 1 here using the 10.1 interface, sub interface 20, 20.1, and 99 on the 30 sub interface. So this is the standard topology that we're going to use when referring to the issues in the next couple of slides. Missing VLANs. So on switch 1, we're showing interface fast Ethernet 6 switch port. So just to highlight, we're looking at the switch port that the host is connecting to on switch 1. So the switch port is enabled and it's running as an access port, and it's VLAN 10 and it's inactive, tagging is enabled. So the fact that it is associated with VLAN 10 and it's inactive will tend to tell you that there's something missing regarding VLAN 10. Generally, you can delete the VLANs and not remove the VLAN associations with each port. So that's the case in this scenario. Switch port issues, and this one we are looking at the switch port interface trunk. It is running on VLAN, it is trunking off fast Ethernet 0.1 and its native VLAN is 1. It's using 8021Q, and it's saying I'm routing 1, 10, 20, and 99. And you're going, well, that's correct. That's the subnets that we're all doing. Well, if we go back to slides, yes, it's VLAN 99, 20, and 10, the native of 1. So that works out. So that should be good. Now, what could be the issue is the other end not configured with the correct trunking encapsulation, or somebody's put a native VLAN other than native 1. Alright, when we're looking at switch port 6 again, on switch 1, which is our PC is connected to it, and we're looking at it being a member of access VLAN 1. So if you look here, it's at the default configuration of VLAN 1. So we don't have our switch port associated with VLAN 10, so it will not provide connectivity to our PC. Our configuration, we're basically doing a show interfaces, including our trunk ports and a trunk interface. So we have our gigabit 00 being down, our 001 is up. It's using the trunking protocol. It's got VLAN 1, 10, 100, 20, and 99. So we've got a problem because the subinterface 1.10 was configured with a VLAN ID of 100 rather than 10. So simple typos will be our most common mistakes in configuration, and that's across the board with any configuration we do. It is going to be our most common mistake. Now again, I must stress from this point forward, again, labs and packet tracer activities are crucial to understanding now. We are doing switching and routing configuration, and by doing the labs, you are getting to remember the command structures by doing them and understanding how they operate by doing those typos and doing our fault finding. Now, if you get totally stuck and you're doing a lab scenario from scratch, don't get overly frustrated. Worst case scenario, save the file, the PKA file, and email it to me. I can open it up and tell you what's going on and send a reply back to you. Okay? Yes, it's not going to be quite as fast as we would be in a classroom, but at least I can look at what's going on and tell you what the issue is if you haven't been able to fault find it yourself. Now, we can schedule a Blue Jeans if you want to do it live, or you can do it, just send the file to me and I'll send it back with a explanation of what to look for. Up to you. They're the options. quite happy to go through all those with you. And hey, James is back. So what did we go over in this module? So basically we had a look at inter-VLAN routing, how it forwards traffic between the VLANs using the options of legacy, router on stick, or layer 3 switching using SVIs. We then went through, as a reminder, of how to create the VLANs, how to set up a trunk interface, and we talked about setting up sub-interfaces on a router. Then we looked at how to convert a switch port into an interface so that we can provide routing on a multi-layer switch. And then we basically looked at troubleshooting techniques in a nutshell. Now, all of this was done using IPv4. We didn't go through the steps for IPv6, but basically, as you'll learn, most of our interface commands and addressing commands, differences between IPv4 and IPv6 is the v6 after the IP command. Okay, so we can still do it that way, just it requires a slightly different configuration. So we finished off going through the most common items for troubleshooting with this inter-VLAN solutions, and reinforced the fact that we need to do those lab exercises and packet tracer activities to help us cement the command structures into our psyche, because we need to understand how to use the command structures, get used to the interfaces, because we will be building networks with these solutions embedded in them, and they will be timed. And this beautiful thing called packet tracer, we can set time limits in it, and it records every keystroke, so we can find out exactly what you're doing when it's an exam, just to give you a bit of stress. Don't worry about it, we've got plenty of time between here and November, basically where exams will be. So by then, if you've done all the labs, you will be comfortable with all the solutions. Now, I will start putting up additional activities as we move through to help cement and reinforce material as we go through, in addition to the standard labs. So that brings us to the end of this one, and I'll turn off that one.